Hello everybody and welcome back. In this video we'll be discussing problem 2 of the 2020 AOIME. The problem reads, let P be a point chosen uniformly at random in the interior of the unit square, with vertices at 0, 0, 1, 0, 1, 1, and 0, 1. The probability that the slope of the line determined by P and the point 5/8 is greater than 1/2 can be written as m over n, where m and n are relatively prime positive integers. Find m plus n. So this is a geometry problem, so we're obviously going to need a diagram, and here it is. So we have to label the coordinates, of course. Let's let this be 0, 0, that be 0, 1. This is going to be 1, 1, and this is going to be 1, 0. And now we have our unit square. So we're basically trying to find the probability that the slope of the line determined by P and the point 5/8 is greater than 1/2. So let's try to find this line that they're talking about. So we have a point and we have a slope. So we can use point slope form to find the equation of this line. If you don't remember, point slope form is y minus y0 equals m, where m is the slope, times x minus x0. Y0 here is 3/8 equals m, which is 1/2, times x minus 5/8. Simplifying this, you get the equation y is equal to 1/2 x minus 5/16 plus 3/8. 3/8 is 6/16 minus 5/16 plus 6/16 is 1/16. So we have a plus 1/16 over here. So let's draw this line. So let's say that over here is 1/16. So this is our initial point of the line, and then it's just going to go like that. So this line isn't that straight, but it will do. Alright, so what is this what is this y coordinate going to be here? Well, we plug in 1, so we have 1/2 plus 1/16. That is going to be 9/16. So here we have 9/16. For line, let's just draw the actual point P. Not P, sorry. The point 5/8 So the point 5/8 would be around like, doesn't really matter. Let's say around there. Yeah, because it has to be below 9/16, and this is about like halfway of this the width of this unit square. Okay, so now let's actually think about when the slope is greater than 1/2. Well, obviously the slope would not be less than 1/2 if it's on this side of over here of this line over here. So we know that the region we want, it has to be on the other side of P over here. But you have to be careful because it's not the full region, this full region over here. We have to be careful because if the probability will be negative over here if we put it beyond this line. So it has to be in this shaded region over here. Now this is just a trapezoid, so we can find this area pretty easily. Well, we know that this is going to be 3/8. This is going to be 1/16, and we just need the height. Well, this is going to be 5/8 because this point P is 5/8, and now we can easily find the area of this region. So we have the sum of the bases, which is 1/16 plus 3/8, which is 7/16, and we divide that by 2, or which would just be 7/32 times 5/8, which is 35 over 256. However, this isn't the only region that satisfies the given requirements in the problem. If we just extend this vertical line we drew, we see that this trapezoid over here also satisfies the requirements given in the problem. So we also need to find the area of this trapezoid. Again, we can do some. We can find the lengths of the bases and heights. The height, since there's only one height. So let's see. Let's first find the bases. So we know that this is 9/16, so we know that this is going to be 1 minus 9/16, which is 7/16. And that this is the first base, and then let's see if we can find this second base. So we have this is 5/8, 3/8, and this total length over here is 1. So we know that this is going to be 5/8. And the height is just this over here. And that is going to be 1 minus 5/8, which is 3/8. And now we can find the area of our trapezoid. So we have 7/16 plus 5/8 over 2 times 3/8. So 5/8 plus 7/16, if you do the math, you will get 17 over 16, and we divide that by 2, so we have 17 over 32. And then we multiply that by the height, so we have times 3/8. This is giving us 51 over 256. Now we have all the regions that satisfy the problem, so we can add these up. And luckily these add up easily because they have the same denominator. So we have 51 plus 35, which is 86, I believe. So we have 86 over 256. So we sum up the numerator and denominator, and we get our final answer of, I think it's, oh wait, this is not simplified, so 43 over 128. Now that's simplified. Adding these both up, we get our answer of 171. And we are done. Hope you guys enjoyed. Be sure to leave a comment about what other videos I could do. I'll catch you next time.